Hello everyone. For this problem here, we're going to factor completely the following quadratic. We've got a 16v squared minus 9. So the same as we've been doing before, we want to run through our checklist to see if we can see what we can do here. And to get started, we're going to check to see if there is a GCF in this quadratic. So I've got a 16v squared and minus 9. I'm looking for any common factors between these two, and I'm not seeing any. So nope, no GCFs. Next, I'm looking for what I'm looking for is to see, is this thing a special quadratic? So those special quadratics are the difference of squares, or for the product of a binomial squared. And really the tip-off is to look at your C term, and I want to see if that C term is a perfect square. And it looks like it is. 9 is a perfect square. 9 is equal to 3 squared. So this is looking like it could be a special quadratic. If I take a look at this first term, I've got 16v squared, and it looks like that is actually going to be a perfect square as well. So what I have right here is the difference of perfect squares, or difference of squares. It's the difference because I'm subtracting these two things. So what I can do then is use the difference of perfect squares formula. Let me get rid of this here, to factor this completely. And to find the difference of two perfect squares, or to factor the difference of two perfect squares, it's always going to have the format of the square root of this minus the square root of this. So I am going to have a 4v, which is the square root of 16v squared, minus 3, which is the square root of 9, and it's going to be multiplied by the square root of this, 4v again, plus the square root of the C term. And if you were to multiply these together, you would get the middle terms to drop out, just like we're missing a v term, a v to the first power, and you'd get back the 16v squared minus 9. So again, difference of two perfect squares is going to be the square root of the first term, always in the first spot on that binomial, and then the second C term, the second term in your difference of squares, the square root of that will be the last terms in each of those binomials. The only difference is one of them you're subtracting, one of them you're adding. So let me just write that cleanly once more. We've got a 4v minus 3 times a 4v plus 3. And there you have the completely factored difference of two perfect squares.